Hi everyone, welcome back to Mr. Edmond's channel. This is Jan 2026 P4 walkthrough. Please don't forget to subscribe, like, share the content, leave a message for me if you need more clarification, or let me know what you need me to cover in the next video. Thank you. Question 7. It looks scary. The diagram looks scary, but it's not hard. Let us see what we have. So we have the curve here, and then we have the equation of the graph over there. Then the first question, they are asking us to find a point P and point Q. They are given, and at this point Q, the y coordinate is pi by what? Pi by 4. And they're asking us to find the x coordinates of P and the x coordinates of Q. That means if you have the y, we just have to substitute in our equation to get the value of x. Get a substitute. So when we substitute here, we have x squared into x squared tan of pi by what? Pi by 4 plus 32 into pi by 4 all squared over pi squared. This one equals to what? Equals to 11. We try to solve this quickly. Then what you know is that the tan of pi by 4 is just 1. So that is x squared plus 32. I'll write this as 32 in over pi squared. This is multiplied by pi squared over 16 equals to 11. So this pi here is going to cancel with that, and as well as I'll not cancel anymore. I have x squared equals to 11. This is going to be 2. 11 minus 2. That means x squared is equal to 9 square root. So that means x is equal to 3 or minus 3 when square root. So you can see that the q is which is minus what? Minus 3, and the p is the 3. That's the first part, as simple as that. We go on part B. Part B is asking us to use calculus to find the dy dx. Now, I'm going to write the equation here. The equation is x squared tan of y plus 32. This is 32 y squared over y squared equals what? Equals to 11. Let us get the derivative of this. Now, this is implicit differentiation. So this is the product. Remember, this is the product rule over here. So this is one value and this is one function. So what's the rule over here? So you get the derivative of this, which is going to be 2x multiplied by tan of y, plus you owe this a constant. You owe now this is a constant, x squared. The derivative of tan is 6 squared of y, by now multiplied by the y dx, implicit differentiation, plus the derivative of this is 32 over pi squared. I'm separating it so you can say this is just a constant, multiplied by the derivative of y squared is 2y, dy dx. This equals to the derivative of this, which is 0. If I one step, let us get the dy dx on one side by themselves. Okay, now that means we have x squared 6 squared of y plus 32, which is going to be 64 now. Plus 32 is going to be 64. We can write 64. Hold on to this time there. Okay, which is going to be 64 y over pi squared. All of this is y dx. This one equals to negative 2x tan of y. Now, but they're looking for the exact value. The exact value at what point? The exact value at p. But we know that at p, y is pi by what? Y is pi by 4, and the x value is 3. Remember, the p is the one that is on the positive side. So we just substitute from here. We don't need to simplify it further. So when you have the 3 over here, so you have the 3 squared, so this is 9, and then you have the 6 squared of pi by 4, you can press on the calculator this, and then you have this one over here, 64 multiplied by pi by 4 over pi squared. All of this is dy dx. This one equals to 2, negative 2 into 3 into tan of y, which is equal to 1. Now this is going to be 2. This one over is going to be 2. So you're going to have 18 plus, what I will do for this one here, because this is the multiplication, I'm just going to write it. I'll just write this because you can do it mentally, but you're writing it as 64 over pi squared multiplied by pi over 4. So you cancel this out like that, and then you cancel this one here, becomes 16. It becomes 16, such that you have this as 16 over pi. 16 over pi, all of this is the dy, dx. This one equals to, on this side, what you have just minus 6. So your final answer, what you have here as your final answer, you can try to simplify it over here. So you have 18 pi plus 16, all of it over pi dy dx equals to minus 6. So you can see that your dy dx, the pi multiplies this side, so you have minus 6 pi over 18 pi plus 16. You can divide everything by 2, so you have minus 3 pi over 9 pi plus 8. That's your dy dx. Now part C of the equation says that work out the value of the gradient of the curve at P multiplied by the gradient of the normal at Q. Now the gradient of the curve at P is what you have in part B. Now they want you to get the multiplied by the gradient of the normal at C. Now there's only one trick you have to see here, is that, this is part we are dealing with. We know the gradient at P, which is over here. Now we need to find the gradient of the tangent at what? At Q. Now at Q, the only thing that changes here is that the substitution here is 3. Now, but at Q, the substitution is going to be minus what? Minus 3. That means the gradient is going to be, the gradient of the tangent is going to be this, but now positive. It's going to be 3 over 9 pi plus 8. That's the only thing that's very key here. I have to see that the same gradient, the same differentiation, but when you reach here to substitute in, at P you substitute in 3, at Q is going to be negative 3. So the gradient is 3 pi over 9 plus 8. That means, in that case, that means the gradient of your normal, remember it's always negative what? Negative reciprocal is going to be the negative of 9 pi plus 8, all of it over what? Over 3 pi. That means parts what they're looking for. They're looking for the gradient at P, which is minus 3 pi over 9 pi plus 8, multiplied by the gradient of the normal at Q, which is just exactly the same thing, but just reciprocal. 3 pi. I can put the negative here so that we can see quickly that we are getting the answer as equal to what? As equal to 1, because everything is cancelling out and the answer is equal to 1. That's part C.